So what I'm going to talk about is Flipkart and what we do at Flipkart as part of analytics and decision sciences. Basically the purpose of this talk is more than anything else to cover some of the key areas we work on. Obviously we work on a lot of different areas. So what I'll try to do is show some one or two use cases of what we do at Flipkart, and hopefully they'll give you an idea of the organization itself. Before that, for 2 or 3 slides about, and I'll tell you why I'm showing this, right? So first thing is, this is an industry which is growing at a tremendous rate because of internet penetration, right? Internet penetration, if you look at it, it's an extremely populous country where the internet penetration is going to grow dramatically over the next few years, and particularly the online retail. And the reason I'm showing this, and this is the scale of the problem we are looking at. So that's the sort of long and short of why I showed the first 2 slides, even though this is analytics and a data science conference, is that to understand what is the scale of the problem, right? And this is important because any internet scale company, the key thing one has to remember is, it is how do you solve problems at that scale? How do you solve problems at that scale? And these are very straightforward problems that a mom and pop retailer solves using his or her sort of notebook and calculator and so on. But this has to be solved at this scale. That is the key thing, right? 150 million plus users, 80 million products. Now that's close to 100 million products actually, and so on, right? So that is the important thing. And that scale, along with that scale comes a very large scale data set, right? And this is the scale of data. To be honest, I'm not an engineering leader, so this is not something I built. It's something built by the engineering teams at Flipkart. And basically, the way Flipkart works is there are a bunch of engineering systems. All of them generate data, and all this data gets ingested into the Flipkart data platform. And there is also a data platform and an ML platform on which you can launch models at scale, right? Business categories, so on and so forth. And then data-assisted machine decisions, which is listing quality, selection quality, personalization, fraud detection, a lot of things we talked about in the previous talk, right? So how do we go from, so the goal for Flipkart always is that as we start maturing, as we become more and more mature, how do more of these decisions become machine-assisted decisions, and we keep on building on that so that the scale can be addressed. Right, so this is essentially, all of these first 5-6 slides are to talk about scale, right? We do 50+ product launches a week. Each launch goes through an A/B experiment. So data is never the problem. What you do with it is what is the real challenge. Long-term experiments to assess impact, real-time analytics, all of these keep going on all the time, right? And what is the span of what we do, right? It's analytics and decision sciences is a horizontal function which looks at all kinds of things. It looks at product insights, life cycle, understanding customer lifetime value, demand forecasting, market cohorts, understanding users deeply, building recommendation systems, building other systems to improve customer experience, so on and so forth, right? Traffic insights, pricing, product assortment, supply chain, seller, trust, safety, all of these things, right? So we it's a fairly large organization which is building products and solutions in all these areas. So what is the power of this data, right? So at the end of the day, just the fact that you have 150 million is a pretty substantial part of the country's population, right? 150 million registered users. And when you have that scale, you understand a lot about commerce in India, right? So you understand where are people buying, right? For example, this is Bangalore. Where do they buy more? Where do they buy less? Given it's online, but still it gives you a pretty good idea. What kind of books do people read, right? This is a very sort of, I pretty much have a pretty good idea of who reads what and so on. So the point here being that you have a pretty good idea how the ecosystem looks like. Who wears high heels, for example? Who wears high heels? How many people buy high heels? How high are the heels? So on, right? You can ask any question and you have answers, right? Are people buying mobiles or laptop, right? You can look at this and you say, like, literally desktops, laptops are dying, and this hasn't changed for the last 2-3 years, and that keeps getting redder and redder as you keep going, right? Thing, right? So that's essentially what just having data does. Just having data at this scale tells you things about commerce in India that very few people can tell. Right, so that's the thing. So now what do you do with this data? And then here I'm going to talk about a few use cases of using ML, and last couple of examples are on computer vision, deep learning, and so on. How do we use this? Right? I'm going to go deep into 2 or 3 problems which are fairly straightforward in retail, but how do you solve it at this scale is the real challenge, right? So first is selection assortment. Okay, what do you carry? So for any retailer, even if it's a mom and pop shop, if the Aishwarya store in the corner of the street, or whether it's Flipkart or whoever it is, I think one of the biggest problems is what do you carry? What assortment do you carry? Yeah, but the expectations are very different from e-commerce versus these mom and pop shops, right? So 2 aspects of assortment that you carry are depth and width. What does depth mean? So I'll talk about both of these, right? What depth means is if I have blue arrow shirt, full shirt, for blue formal arrow full shirt, right? How many blue arrow full shirts do I need to carry in my platform for people who are shopping for formal full shirts arrow to find enough selection that they consider me seriously? Right, that is depth. Width is what kind of items do I carry? So do I carry a shirt? Do I carry shoes? Do I carry an automotive spare part? Do I carry musical instruments? That's width. So that's width, depth. So how do you figure out what is the right level of depth and width? The obvious answer is carry all depth, carry all width, but obviously there is a prioritization. You have to figure out how you invest. What do you go? There are finite resources, finite number of people. What do you bring on board? Finite number of sellers. Where do you put your resourcing energy? Right? So a few quick definitions. Let's talk about depth first. Depth, as if you remember what I said, right? Arrow blue formal shirt. How many of the arrow formal shirt, if somebody is looking at it, how many should I carry? For somebody to feel that, okay, here there's a good, much better selection than my local clothes store that I buy here. Right? So you define a sort of term called market SKU. Market SKU is the unit of demand as seen by the consumer. Right? The consumer is not, when you're looking for a shirt, you're not looking for this particular shirt. What you're looking for broadly, typically is, I want a formal shirt, maybe I'm particular about brand, it should be a full shirt, maybe it should be an arrow shirt, okay? That set of attributes form what is known as a market SKU. For example, a Nike basketball shoe in the 2,000-2,500 price range. So how do I determine what's a market SKU? We mine a lot of search queries, look at these cluster of search terms and figure out how do people search and what is the sort of unit of demand. The best way to describe it is unit of demand. Second is threshold. How many should I carry? If I want to be seen as a preferred destination for Nike basketball shoes in the 2,000 to 2,500 price range, how many types of these Nike shoes should I carry? Should it be 5, 4, 2, 1, 10? Does it make a difference? Right? That is, okay, and so basically how do we solve this problem? That's the problem statement. So the first thing you need to do is, it's very straightforward, right? First what you do is you build a model, taking all the attributes. This is a demand model, right? We build a model which predicts demand, and it's a function of a lot of different things, right? What is the discount, seasonality, product rating, listing, speed of delivery, blah, blah, blah. There are a whole bunch of attributes, some of which are shown here. These are huge thing. You build a model for demand. So for first, you get confidence that you're able to build, you understand demand, okay? And if you look at it, one of the attributes of that model is also number of styles and SKUs, right? So that's one of the attributes, right? So now you do what typically you do in mathematics. You take, do a partial dependence plot, which is like a partial derivative, and then you see things like this, okay? So what is this actually? What it's showing is, as you keep increasing styles, when you have very, very low number of styles, there is actually no demand, right? If you have very low number of styles, people don't even come to you to shop for that particular product, right? So you don't go to a cycle shop and ask for a scooter, right? You don't even, if you have very little selection, you don't even shop. At some point, the selection is enough. In this case, it's 10. That demand starts picking up. So this is actually build a demand model and then figure out a partial dependence plot. So this is essentially, in some ways, you can think of it as, this is how, if you remove all the other attributes of demand, this is how demand varies with number of styles. Right? This is a very complicated problem. It's not something that you can derive directly, right? So then, at some point, you will see that if you increase the number of styles, maybe you only need 2,000 to 2,500 basketball Nike shoes, 15 varieties. After 15 varieties, consumers don't care. There is enough choice for them to choose. So what is that number? That number in this case, this is some, I think some kind of shoe. I forgot to put what it was. And it's, I think, open footwear. It is around 16 or 17 styles. So you can mathematically derive, through a machine learning model, actually derive how many, for every of the 80 million listings, right, or maybe few hundred thousands of products, how many styles do you need for it to be a value proposition, for it to be that consumers find this a destination? Yeah, so that's one problem. So that was about depth. Now, how do you solve for depth? Works for what we call head selection, which is products like shoes, suitcases, shirts, pants, mobile phones, laptops, so on, which everybody knows is there. You will shop from the places where it's more, there's more variety. Now, the second kind of problem is people come to e-commerce because they find things that they cannot find anywhere. Like I was looking for something I bought last week from Flipkart was this I play flute, so I found this, I needed something to clean the bore of the flute. Where do you find it? You can't go looking around in shop. That's where e-commerce solves these problems, because they have a very wide selection of things that exist, right? For width of selection, how do you solve? So that is the next problem, right? Oh, sorry, I went the other way. Yeah, so for width of selection, we do something, right? We look at search queries both from Flipkart and outside as well. And then every week we get 15 million search queries from 1 billion user sessions. And then you use NLP to categorize and cluster these queries. This is a fairly complex problem as well. Then identify clusters where your click-through rates are very low. That is your gap in demand. So that is the gap between supply and demand, where your click-through rates are low. Those are the things that then get directly pushed to sellers. And then we have a seller affinity model, which says for this cluster, this query cluster, which is the likely seller who can fulfill, and I send it to those sellers. And this is sent as a seller intelligence dashboard. And then they are able to say, okay, if I had this product, there is reasonable demand for it. Right, and we'll prioritize based on demand. So that's essentially how you build depth of selection. Yeah? So another example, right? This is another example is review quality score, right? You've seen sort of nobody buys today anything in e-commerce, and in fact, if you look at some of the markets, right, we have even offline purchases are bought based on online reviews. people look at online reviews and then they understand what's good and so on. So we had a pretty sort of very, very rudimentary algorithm say several months back on how do you look at reviews, right? We used to have a simple algorithm which said which of the reviews have a most number of upvotes, and when you have a lot of upvotes, then you assume that is probably a good review. And then as a tiebreaker, we use recency of review. It was as simple as that. But it doesn't solve the problem. Okay, so look at that review. That was very highly voted. Perfect to grind owner's head, right? It doesn't tell you anything. Yeah, it probably tells you it's not a good grinder to buy. But it doesn't tell you anything. Like, good product delivery is too good. So look at the second one. Packed awesomely, works even with no extra harsh sound. This was the most upvoted. But the reality is, I don't even know what that product is, let alone knowing about the product and so on, right? So upvote is not a good proxy for helpfulness. There is no measure of quality of review. They may talk about all sorts of service-related aspects, or like in the first one, just somebody making a funny joke to get out there, this thing, right? So on. So you have to figure out better ways to figure out what reviews to surface. And it has to be neutral, because at the end of the day, it can't be based on review score. Higher rating shouldn't be pushed up, because then you're creating a biased view for the consumer. For us, at the end of the day, we are a platform, right? We have sellers from everywhere. We are a platform. Our goal is to show the best product and as honest reviews about the product and as detailed reviews about a product as possible. So what should a review have, right? It should have relevance, it should have depth, it should have other factors related to service and all that should be secondary, but mostly it should be very, very relevant, and it should be very structured, listing out pros and cons, so on and so forth. Okay, so this was the model we used, right? So basically, I will go into the model, but basically what we did was, we start out with, for every product you have, so we are now, the problem statement is we are trying to figure out which review best describes the product, okay? And that's what we are trying to do. So the best way to understand, so products can be described based on their attributes. Where do you find attributes? You find them in the catalog. So you extract attributes from the catalog. Then Professor Dakshinamurthy talked about word2vec. So basically, it's again used for the same purpose, extending. So you got a bunch of attributes. Now I want to, like he talked about cost and price and so on and so forth. I want to extend this into similar set of features or attributes. So you use a word2vec model to expand the cluster, to expand the seed list. Then you go to the entire corpus of the text of the reviews. Then from that, mine sort of descriptors of these seed words, and build sort of phrase clusters, and also look at other sources of information which wasn't captured here, but they are repeated often, build other independent clusters that get created, and then compute the weight for each of the clusters, right? So I'll go a little bit of detail, right? So basically, extract seeds using catalog data, then extend the seed, picture gets extended to image, pics, photos, so on and so forth. And then extract phrases from review tests. These are adjective noun combinations, so that you get better understanding of what's going on. And then build the cluster phrases, and then extend, which were not part of these clusters, look at them, look for patterns there, and add those features as well. And then finally, you can assign weights based on cluster frequency in the entire corpus. So things that are described a lot more probably are more important, and a lot more often, and so on. So you build a sort of a scoring algorithm. And then the weights again can be, again these weights are based on mining the entire corpus of reviews and seeing what are more important, what are not. And you can do some nice tweaks like creating a decay function, because if somebody goes on and on about camera 10 times, camera may be a very important feature, but you don't want to listen to 30 things about the camera for a mobile phone. You want to listen to a few things about camera, about a few things about memory, few things about features, other features, so on and so forth. So you do some decay functions to take care of those kind of repetitive about a single attribute, so on. And finally, you give incremental weights to things like describing pros and cons to bump up the score. And finally, you come up with a review quality score. right? And the last piece you hear is for the length of the review. Which very interestingly, what we realized was length of the review had very little to do with, if you accounted for all this, the incremental value of length of the review was pretty much null. So it's almost like a tiebreaker in case you don't have anything else to do, you just add that as an additional thing, right? So now you look at the reviews which were scored high in this, right? You will see that these were automatically generated, and you'll see that these have much more detailed description which makes sense, which describe the product. It talks about material quality, talks about was it breaking or not, it talks about features like rubber plastic lock, it talks about low noise, nice design, all kinds of things, right? Once we put this, again we run everything. Whenever we build a new model, we run it through an A/B, right? So this is again run through an A/B, and what you see from the A/B is again that we were able to, product page view is a very, very important metric, right? So somebody sees an impression. So these are e-commerce terms, right? So when you search for something, what you get are impressions. If you click on them, it's a product. You get into the product page. That's a product page view, right? Product page view is a very, very good indicator of engagement of consumers. What you clearly see is total people who read these, and when these reviews were changed, you dramatically improve the product page view. So that's, and we increase units, conversion, all of these things. The last thing I'm going to, no, the third thing, then I'll talk about the customer image and vision and so on and so forth. But before that, this is the other problem. Price elasticity, right? Again, this pricing. So how do you do pricing at scale? Again, the problem is scale, right? So you have to build a system that accounts for scale as well, right? Basically, we have, like I said, 80 million listings. And when you have 80 million listings, how do you figure out what to price each of these listings, and where do you improve margin, where do you improve revenues, so on and so forth, right? So that's the problem. So basically you have product sales. Again here, the first thing is building a demand prediction model. So we built a ML model that would predict demand. And then after that you can filter, sort of understand model accuracy, where is pricing a significant variable, then based on that, where is it where is the sensitivities to elasticity, so on and so forth. Then you run an optimizer and provide a product level pricing recommendation, right? So the pricing itself is elasticity itself is a complex problem, right? Because first of all, here are the things you have to build. Forget about all this thing. I just pulled, lack of time, I just pulled out the thing. This is not just kind of a very vague representation of what happens, but look at the English below each one of these, right? These are the factors which impact pricing and demand, right? Our pricing algorithm and demand, right? First thing is you're trying to understand what the demand is like. So there is a sales lag. So those are the first two are the time series pieces. What is the momentum that is in the system? The display effect, right? What are the, how often is are these impressions being shown? That is a big driver of sort of the demand response function. Availability is it out of stock? How often is it out of stock? Is it available? So on and so forth. Then self-price effect, self-price elasticity. Then cannibalization elasticity. So for example, if I have a Nike shoe priced at a certain point, its impact on its demand is a function of similar priced Nike shoes, and what is the impact of that? So the point is, just because I bring down the price of this Nike shoe, is it going to dramatically increase demand, or is there a shoe which is very similar, which is maybe you decrease this price by 50 rupees, but there is another shoe which is almost identical, which is down by 100 rupees. So by decreasing this by 50 rupees, you're not going to dramatically increase demand. Again, this has to be solved at scale. So how do you use co-browse data and so on and so forth to figure out what should be a similarity-based cannibalization impact? And then there is a price-based cannibalization impact. Those are both things. Similarity-based is more substantial substitutable products, which may not exactly be a price competition. Price-based would be identical products with very similar products with different prices. Then there is competitive price cannibalization, which is what are your competitors doing and what is their prices. So all of these go into the system, right? So now the other complexity of the problem is when you actually plot demand versus time, right? See, that's what makes these problems very, very complicated and you need ML and so on and so forth, right? That's what it looks like. It's not a nice linear that you learn in your economics class, right? 100 rupees, 50 units, 110 rupees, 40 units. It's not a straight. This is what demand, because there are so many factors. Why does it look like this? Because these are the attributes which drive it, right? So you have to, again, this is similar to that one, it's a partial dependence plot, where you have to find the actual curve, what it looks like, once I remove all these attributes from the equation. Right? So that is what this is doing. So basically what it's doing is it's removing that, and then that's what the actual demand curve actually looks like. Now that you can use and start building your strategy. So that is for each SKU, you build a demand curve like this, right, where you understand the elasticity. Now you run an optimizer, and the optimizer is essentially trying to do this, right? You have a margin and you have sort of demand, so demand elasticity, sorry. And what are you trying to do, right? Where you have high elasticity and high margin, you try to milk that. That becomes like a cash cow. Where you have low elasticity and low margin, you try to make it more expensive so that you can extract more margin out of it, because it's not going to dramatically impact demand, and so on and so forth, right? So each area, so what we do is the system has to actually figure out where the opportunities for margin utilization, margin creation is, and where is the opportunity for driving incremental units, and being at scale, being able to do this. This is an example of some experiment we did. Obviously, we have removed all the key data for confidentiality purposes, but that's essentially what we do with this, right? So basically, if you have to summarize this, first of all, sort of build a ML model to sort of predict demand, then do a partial dependence plot, trying to understand, to separate out the impact of price versus demand, impact of price on demand, to separate out in a good way, and then use that to figure out where should we invest, where should we divest, where should we invest, and where should we extract margin, right? So that is the thing, right? Then there are many other areas that we work on, right? Before we go there, one of the things I wanted to say is, all of these problems, right, I think where a lot of the complexity and machine learning and scale of data becomes interesting is that all of these 300 things are going on at the same time. It's a very dynamic system. You're changing prices, you're creating merchandises, you're doing deal of the day offers. In the middle, there is a sale coming in. Then there are issues with maybe delivery is speeded up or slowed down. All of these impact all of these things. That's what makes it interesting. Now going into some other areas, right? This is our work on vision and so on, right? One of the biggest use cases we found in Flipkart was applying it for actually extracting. See, one of the things is catalogs are built by sellers. These sellers are your regular mom and pop shops, or slightly bigger, and so on and so forth, right? They don't have very sophisticated technology. Image quality is sometimes an issue. They may not fill all the attributes and so on. So catalog quality is a big customer experience issue, right? So do you find all the aspects of a product that you really want to look at? And that's the problem this is trying to solve, where here we are trying to see, can we extract features of the product and put it in the catalog, even though the catalog is incomplete and so on. Here the other thing is, it's purely QC of image, improving the quality of image. If you look at it, you see a shadow. Can I remove features like this that are not pleasing for the consumer? Can I solve for those? This is another use case. Third use case, this is a very interesting use case, is what we call MRP fraud, right? Which is essentially this person is calling out a $7.99 MRP and saying it's $3.99, even though when I mine that, it's actually $3.99. So how do I extract out images and so on and so forth from there that actually can be used to figure out whether somebody is doing MRP abuse or not, right? So these are things. Similar, there are multiple other use cases like this that we can use, right? So I finished one time. So keeping the track record going. So that's pretty much it.